Hello everyone, welcome to the episode 36 of Solid Saturday. The guest we have today, Pablos Coleman. I met him in 2018 actually during the Data Science Go conference, and since then I am connected with him and I'm following him on the LinkedIn. So, what should I talk about him actually? I can't describe him in a single word. He is an inventor, he is an advisor, he is a founder, he is a faculty member, he is a public speaker, and most importantly, he is a top class hacker. So, let's welcome him and hear more about his career journey. How did he find his passion and managing to lead his area of interest? So, thank you so much, Salman. I really appreciate your time and consideration to be a guest on my podcast.
Yeah, my pleasure.
So to begin with, actually, as I mentioned in the introduction itself, that you tried to be everywhere and you are doing well, actually. So I would like to ask is like, what do you enjoy the most and why?
Well, I think there's most of my work has been in trying to advance new technologies, invent new technologies, bring them into the world, and really show people the potential that we have to really use technology as a force multiplier, as a way of attacking some of the biggest problems that we have in the world. And so, yeah, I mean, I get to do a lot of different things that are related to that. But my favorite thing is succeeding at doing something new with with a technology. That's what I'm good at. I like to do things for the first time. When it's time to do things in a methodical and repetitive fashion, I'm probably not the guy you want. But when it's time to do something that hasn't been done before, that's what I like to do. And so I really try to optimize for being in situations where I'm able to help move something forward and do something new.
Yep. So it is more or like you are a true inventor, I guess, because you would like to do
Yeah,
something which is not there before.
right. And I'm one of the few people who've been lucky enough to get to work as an inventor. You know, that's a pretty unusual opportunity, because most people who are inventors, there's no job for you. There's nobody who has a business card that says inventor on it, except for me. And it's because we don't have a good way of, those are pretty unusual people, and we don't have a good way of categorizing them, and they don't fit into our businesses and organizations well, and they add a lot of risk, and you never know what they're going to come up with. And yeah, so inventors don't quite fit in businesses a lot of times, and they don't quite fit in the scientific community a lot of times. And so I think they're sort of underappreciated and underrepresented and undersupported. And so but we really, really need them, and we really need to figure out how to support the inventors, because they're the ones who figure out what's possible, and they're the ones who give us all our new technologies.
Yep. And when I actually saw your profile first time in 2018, the first point that I noticed in your profile, it is like, you have like patents, like so many, like, 70 almost, which is like
Yeah.
huge for me. And I never visited anybody's profile like that, like, who has like n number of countless kind of patents. So, do you like to, share any particular patent innovation with the audience, which you always feel like, that is the best one or something like that?
So with patents, I worked for Nathan Myhrvold at Intellectual Ventures, and we invested heavily in patenting our inventions, and so that was, that's one of the reasons I have so many patents, is that I worked on a team with other inventors, and we were the most prolific inventors in America. So the thing about patents, though, is all the easy inventions were done a long time ago, right? So these days, a patent tends to be pretty specific, pretty detailed, pretty narrow, very technical, and there's a lot of legal aspects to it. In order for a patent to be usable and enforceable, there's a lot of legal constructs in it. So by the time you actually have a patent,
Mm-hmm.
you know, it doesn't often like represent a you know, like there's not, for example, like there's not a patent for like the iPhone. You know, the iPhone is like 2,000 patents in a product. You know, so a bunch of my patents were probably one of the largest areas in which those patents are relevant is 3D printing.
Mm-hmm.
And specifically, I was the first one to try and advance 3D printing to print food. And so a whole bunch of those patents are related to printing food and using machines and robotics to assemble meals. And that at the time, you know, this is over a decade ago, I was working on this stuff. And so at the time it sounded crazy, but every year it sounds a little less crazy. And so I'm really excited about that because there's a lot of potential in improving the way that we make meals for people, to make it more efficient,
Mm-hmm.
and to make it so that when we're doing that, we can customize meals for people. And that's what a lot of those patents are related to, is that kind of invention work. And so I came up with a bunch of technologies to help do that, and different ways that we could do that. And so that's some of the interesting stuff. There's a lot of different inventions in there, though. Yeah.
That's great, actually, when technology can help,
Yeah,
on some social cause and help.
of course.
So that's great, and thank you so much for sharing. So do you remember that when did it started actually for you, like the idea of innovation, and you invented something when you were young?
Yeah. I'm unusual because I grew up in Alaska,
Mhm.
which is very remote and cold and dark,
Mhm.
and there's nothing much to do there.
Mhm.
But I got a computer when I was, I guess, about 9 years old, and this is in the 70s. So I had one of the first like home computers
Mhm.
that ever that a kid could have, and so I had a computer all to myself just earlier than pretty much everyone else on the planet. And so partly because of that, I had an interest in it, and it was exciting to me. It was like this bottomless pit of puzzles. I was just trying to like learn about it and understand, but I couldn't learn from anyone. There was nobody for 1,000 miles in any direction who knew more about the computer than I did
Mhm.
as a kid. And so it was a big deal just to be able to learn how it worked. I had to just try everything, so I learned in a very autodidactic fashion, and I learned about computers by reverse engineering 6502 assembly language. That's how I learned to program. That doesn't make any sense. Like, nobody would do that on purpose. You can learn to code from YouTube. I didn't have that. So I just had to try changing ones to zeros and see what happened. That was a very, very inefficient way to learn to program computers. But I learned a lot at a very fundamental level about how the computer worked. And then I just constantly had to learn what was new. And so I was able to build a very deep knowledge of computers that I've been doing my whole career. And I'm always only learning the new stuff, and it's just hard to catch up to me. But all along the way, I always felt like I had this superpower, that came from the computer. It came from, like, I could see how someday this was going to have more memory, and someday it was going to have a faster CPU, and someday it was going to be useful. No one believed me, but but I was right, and eventually computers did get fast and powerful and cheap, and we use them for everything now. And I just kind of got lucky in that sense that it turned out to be valuable. But I have always been most motivated by that feeling that we could use this computer to change the way we do something and do it better or faster or cheaper or in a more humane fashion or a more efficient way. That's what I want to be doing, is I want to apply these technologies to change the way we do things and do them better. And that's fundamentally what we've been doing with technology, or in all of human history. This this is what gives us those capabilities.
Yes. Yeah, I saw that in your profile as well, that using the superpowers, and I feel like you are using it very efficiently. That in the society as well alongside. So that's great. And moving towards your recent achievement, that is like you founded your new firm, Composite. So what does it?
Yeah. So Composite is what we're trying to do is reinvent the way that we manufacture things. So in some sense, I described that with using 3D printers to print food.
Mm-hmm.
But that same model could be used to make all kinds of things, as we have like increasingly, general purpose tools for producing things. 3D printers are a good example of a programmable tool
Mm-hmm.
that doesn't care if it ever makes the same thing twice. Right? That's a lot different than most factory tools, which are built to make zillions of the exact same thing, and it's expensive to change. Well, with 3D printers, you could print something different every time, and that gives you the ability to sort of make physical things the way we make software, in a very iterative,
Mm-hmm.
dynamic fashion, where the product cycle is short, and we don't have to guess, so far in advance what's going to work.
Mm-hmm.
We can just try things and steer towards what works.
Mm-hmm.
If you look at the way we do software development now, it's very iterative, and that's not true for physical stuff. And so anyway, so with Composite, what we're trying to do is take that notion and apply it to apparel manufacturing.
Mm-hmm.
So the way we make clothes is turned out to be one of the worst industries in the world. We're very inefficient. The apparel industry produced about 150 billion garments last year.
Mm-hmm.
55% of that is already in landfills.
Mm-hmm.
And 30% of it was just never sold in the first place. That's overproduction. Imagine if the auto industry threw away 30% of the cars without ever driving them.
Yeah.
And apparel is almost as big. Like this is a disaster for humans. It's a disaster for the planet. It's estimated to be almost 10% of global CO2 emissions. 20% of global freshwater pollution is from making clothes. And we're going to run out of water. Like this is one of the biggest problems. So the way we do it, a lot of that problem fundamentally just maps to speculative manufacturing. You're guessing a year in advance what's going to sell. You're manufacturing it in Asia, shipping it back to the US, putting it in a warehouse, eventually putting it in a store,
Mm-hmm.
waiting for somebody to discover it and buy it. And you just guess wrong about what colors, what sizes, the designs, the volumes. You just can't guess perfectly. No one can.
Mm-hmm.
So if you flip that on its head and imagine, okay, well, if we built a magical robotic factory that could make clothes on demand and wait for you to click buy now,
Mm-hmm.
and then we make your clothes and ship them out the next day, then we never guess wrong.
Mm-hmm.
Right now we produce after it's been sold instead of before it's sold.
Mm-hmm.
So we never overproduce, and we never make a product that has until it's been sold. We know who we're making it for.
Uh-huh.
We know what size, what color, what design, everything. We make it for you and we send it to you. There's no overstock, no inventory risk,
Uh-huh.
no liquidation sales, no brand devaluation, no waste, no disposal.
Uh-huh.
And so that whole process is a way of changing the business so that it is much, much better. And we've been doing that. We built one company to test these ideas and ran it for 6 years.
Mm-hmm.
And we never made a product for the landfill. And so it can be better. And this is really a case where, it's an industry that hasn't adopted any technology for 100 years.
Mm-hmm.
And so what we're trying to show is we don't even need to invent new technology yet. We just need to adopt a bunch of the things that already exist,
Mm-hmm.
reinvent how the business is structured, and we can get massive improvements. So that's what we've been working on.
Oh, wow.
Yeah.
That's great, actually. And my second question was along the same line. Actually, you highlighted a couple of points around, manufacturing industries. So
Yeah.
more towards that. So what do you think? Like you already mentioned a couple of things, but if you have to be specific about this, like what ways do you think are wrong in current way of manufacturing any apparel?
Well, I think a lot of it, um, I'm looking at these things from the problems perspective. It's like, what are the biggest problems? What are we going to do to address them?
Mm-hmm,
And a lot of times, the biggest opportunity to make a difference is the gap created between what technology has been adopted and what technology is available,
mm-hmm,
right? And so you're looking for an industry where that gap is really big, right? So, for example, in smartphones, that gap is pretty small,
mm-hmm.
right? Like all the technology you could put in a smartphone is already in there.
Yeah, yep.
But when you look at like manufacturing in apparel, the gap is huge. The last technology they adopted was the sewing machine 150 years ago.
Mm-hmm,
So we have a lot of new technology that could close that gap,
mm-hmm,
right? And so, and with manufacturing industries, you almost always have a pretty big gap um, because for a variety of reasons. But a lot of times especially the lower margin the product is, like with apparel,
mm-hmm,
the higher volume, the lower margin, the more it has been pushed to low cost labor, right? And
mm-hmm,
so apparel is driven by low cost labor. So that's why, as an example of an industry that's ripe for disruption,
mm-hmm,
that's one that sort of checks all the boxes.
mm-hmm,
Other manufacturing industries like automotive, there's higher margins, there's more money in it, they've been able to adopt more technology, so there's a smaller gap,
mm-hmm,
right? Now, they still have problems, but there's sort of less of an opportunity to improve the way manufacturing works in automotive than there is in apparel.
mm-hmm,
So that's kind of one way you could look at it. But this is fundamentally how you would look at almost any industry. What's the gap between what's technically possible, and that changes every day because we get new technologies, right? And what's actually happening in the industry. And so, the canonical example, of course, is things like Uber, where they just ignored smartphones in the taxi industry, right? Because everybody's just doing taxis the way we've always done them. And meanwhile, everybody's carrying a smartphone and they have to call the taxi dispatcher and get a taxi to come pick them up. Like, that doesn't make any sense in a world where you have a GPS in your pocket and Google Maps. And so Uber was able to replace an entire industry with a startup because they closed that gap, and the industry wasn't. I mean, any taxi company could have made an iPhone app, but none of them did,
mm-hmm.
and that's why Uber was able to make such a big impact on that. And Airbnb did it with hospitality, and Facebook did it to media, and we have all these cases. So what I'm trying to help people see is their job, our job as technologists, is to look for those gaps, try to craft a practical vision for how we could close it by adopting technologies that exist. In my case, I'm trying to get past it and invent out into the future, but you don't even have to do that most of the time. A lot of it is just understanding the technologies we have, and figuring out how am I going to use that to close that gap. And closing the gap really means, saving money, saving the planet, doing things in a better way, all those things the gap is the gap between better, what's possible, and where we are, today, right? So that's what we're trying to do. And I always think of things that way.
Yep, yep. That shows actually. So when we are talking about this, I know technology, innovation, and social cause, it's moreover about when you talk about finding the gap and finding out. So it is again like creating a different business line out of it, kind of. So the way you given the example of Uber, they
Yeah.
found something like which is missing, and they found like a different thing, which is kind of idea innovation, I guess. It is more over like generating an idea with the existing problem
Yeah.
and finding the solution towards it. So that's great. And moving towards our next question is again around your as you're talking a lot more about superpowers and how you started using the computers early in your age.
Yeah.
When you were in OQO, I would like to ask
Oh, yeah.
long term, like long form as well. What is that OQ stands for? So you built the world's smallest PC, the first ultra personal computer that was
Yeah.
in a pocket but have all the power of a laptop. Would you like to share more insights to the audience as well, as I am also very keen to learn?
Yeah. So OQO was started in the about, I think the company was started about 2000 or 2001.
Mm-hmm.
And the founding team had made the first titanium PowerBook for Apple.
Mm-hmm.
So they had made the first laptop that was only 1 inch thick. And now that seems really thick, but in those days it was like half of the thickness of a normal laptop. And
Mm-hmm.
that seemed amazing at the time. And what they wanted to do was go even further.
Mm-hmm.
Because, and if you just think about the progression of using computers, they've become, there's kind of two major traditions in computer usage. That one way of thinking of it is you have computers for business,
Mm-hmm.
and personal computers.
Mm-hmm.
And personal computers are really what Apple always focused on. In some sense, you could say this is like the difference between Apple and Microsoft back in the 80s and 90s. It was Microsoft was making computers for businesses, Apple was making them for people.
Mm-hmm.
And and that progression of making computers ever more personal continues to this day. We started out with giant mainframes, and then mini computers, and then microcomputers and desktop computers, and then they ended up on your lap, and then they ended up in your pocket, and now they're ending up on your head, because we're trying to make them personal, right? For a computer to really help you, it needs to be very closely integrated in your life, right? And so, the computer is not very helpful if it's in a warehouse 700 miles away,
Mm-hmm.
right?
Mm-hmm.
But when you can have a supercomputer in the palm of your hand, well, it's starting to get pretty powerful. Like, you and I are all cyborgs now. Like, my brain used to be useful for things like memorizing phone numbers. Like, when I was a kid, my brain was full of phone numbers for all my friends because I needed to know those in order to call my friends. Well, I don't know any phone number. I know my phone number. I don't even know my daughter's phone number. I don't even know it. I don't need to know it because this thing's going to keep track of it for me.
Mm-hmm.
And so I'm already dependent on it. Like, I'm already part computer, and my brain is now freed up to do something besides phone numbers, right?
Mm-hmm.
So the idea is, as we can improve our ability to make the computers useful and let it do things that it's good at, so my brain can focus on things that it's good at.
Mm-hmm.
Then we can make humans more powerful.
Mm-hmm.
And so a big part of that has always been, how do you make the computer faster with more memory, lower power consumption, lower heat output, and smaller? Like, those are all the goals. We want to do all of those things because ultimately, this is a pain in the ass. I have to dedicate one of my entire hands to holding the thing.
Mm-hmm.
It'd be nice if I had the thing built into my glasses, wouldn't it? Or into my contact lenses, right? And as you can imagine, like, a lot of the I/O on a human is on the head, right? It's almost all in the head. The ears, the eyes, the mouth, all of that, not to mention the brain. So we're going to put computers on your head. Like, that's the natural trajectory. That's where we're going. It's just that to get there, we have to make them smaller and better. So OQO was an early attempt to make the leap from laptop to pocket. And what we were able to do is shrink everything in a contemporary laptop to something the size of a passport. It was exactly the dimensions of a passport, but 1 inch thick.
Mm-hmm.
And it had a 5-inch touch screen on it. It had a thumb board, like a BlackBerry or a phone. It had a thumb board. It had a 30 gigabyte hard drive, Wi-Fi, Bluetooth, everything that was in a laptop in those days, but and you could fit it in your pocket.
Wow.
and it ran a full version of Windows. At the time, we were using Windows 2000 or Windows 98,
Mm-hmm.
and that was it was unprecedented. Like no one had ever seen a computer that cool. Like we made the world's coolest computer, the world's smallest computer.
Uh-huh.
It was also, in some sense, too expensive, and it didn't really work out as a successful product.
Mm-hmm.
But a lot of that miniaturization work is what eventually made iPhones and things possible, right?
Yeah.
And so now we live with, this is much more powerful than an OQO, but we're, 20 years later. And the capability of getting all of that into something so small, part of its origin story was at OQO. And, and now the goal is, we got to get past this. This is a milestone. And as you've probably heard, Apple is trying to figure out how to get glasses that can take on a lot of what you do. And of course, they've done that with the watch. This is extremely low power, runs all day. And if you could get this capability in your glasses, that'd be a pretty good start. Just seeing your text messages without having to fish your phone out, hit, thumbs up on them without having to, get a device, ask Siri for, a synopsis of the latest, Game of Thrones episode or whatever you need to know. You could do all that with glasses and not have to, I don't have to dedicate your arms to the job. So it just makes it more personal. And I think that, if you imagine that, like what I said about phone numbers, once my glasses put your name on your forehead, then my brain is going to stop remembering names. Like why right now my brain is wasting so much processing power on remembering a bunch of names for people I'm probably never going to see. But if my glasses could just tell me everybody's name when I see them, I'm never going to take those glasses off. Right? Like that.
Like, brain functionality will be like, humans will use the less brain then. Like a lot of humans.
No. Are you using less brain now because you don't memorize phone numbers?
Yeah.
Or are you using your brain for other things?
Yeah.
Like I think the value, like when I was a kid, probably for you too, like I was in school, I had to memorize, important dates from history, the name of every president, the capital of every state in the US. Those are the kinds of things I was forced. I'd spend a lot of time in school memorizing this shit, which Wikipedia knows. And I never am more than arm's length from Wikipedia, right? And so I could have spent that time on, cognitive skills, analytical skills, learning what to do with the dates, and so like my kid, she doesn't learn that stuff. Like, why would she memorize the names of states? Like she can, or the capitals of states, or any of that. She can look it up instantly. She lives in a world where she's not really going to have much value from memorizing that stuff. So that time in school could be spent learning what to do with your brain, right? We don't need brains to do things that computers are better at.
Yes.
Right? Now we need, so she's learning math. She has to learn that process of like how math works. But she's growing up in a world where like, a computer is going to do the math. And we want that. We don't want humans doing the math the way we had to, when we went to the moon. Well, humans were using slide rules and pencils.
Yeah.
But now, if we go to the moon, we're going to have the computer do the math, and we're going to have the humans do the part that they're good at, right?
Yep.
And so I think that's really important thing for people to work on, is just getting a clear sense of how to augment. We've got to understand computers are tools for us to use. So we want to learn about what they're good for, use them for what they're good for, and then figure out what they suck at that we're good for, and do what, and divide and conquer. And it's that teamwork with computers that's going to make us more powerful and more successful.
Yeah.
And I think a lot of people get scared of that.
Yes. Thank you so much for sharing. And
yeah.
as we are talking a lot more about innovation, right? What are the real challenges do you see when it comes to the innovation?
Yeah, I mean, a lot of it is just this dynamic between what it takes to do new things
Mm-hmm,
and what it takes to do things that we've done before,
mm-hmm,
right?
mm-hmm,
And so, different contexts, different organizations are optimized for one thing or the other. And, startups are good for doing new things in general,
mm-hmm,
right?
mm-hmm,
Um, they're small, basically, in the tech industry, a startup is like $1 million experiment, right? It's a way for us to run a lot of experiments. And they have a high failure rate because uh, we don't know what's going to work. We don't know what team is going to work, what idea is going to work, what product, what timing, anything. So we just have to try a bunch of things, and that's why we have zillions of startups, and
mm-hmm,
they're all essentially a $1 million experiment, and occasionally one of them turns into $1 billion success. So that's the model, and it works as an ecosystem, right?
mm-hmm,
Some people can't get their heads around that. They look at it and say, "Oh my God, it's so inefficient. There are so many failures." But that's how we discover the successes.
yeah,
And the truth is, in almost every context, you know,
mm-hmm,
there's nobody's actually smart enough to figure out what's going to be successful,
yep, that's
right?
yes.
But the process of running a bunch of experiments and finding the one that performs the best, that's very successful,
Mm-hmm,
right? And so whether you're in a company or whether you're an investor in startups or whether whatever, what you really want to be able to do is run a lot of experiments, get a lot of shots on goal, and find the ones that succeed and double down on them.
mm-hmm,
And we have a way of doing that with startups. We don't have a way of doing that in a lot of big companies,
mm-hmm,
right? So in a lot of organizations, the reason they suck at innovation is that they can only invest in things that they're sure are going to work. And their only thing that they're sure is going to work is whatever they did last year. Right? So they're going to do the same thing they did last year. They're going to make it a little faster, a little cheaper, a little better, but they're definitely not going to try something new and radical and different that could be 10 times better,
mm-hmm,
right? Because it's 100 times as risky as whatever they did last year. So the context is just wrong for innovation, right? And so you always need to be looking for a context in which you have a chance
mm-hmm,
at running a bunch of experiments or trying a bunch of different things. And in American business, we used to have R&D departments.
mm-hmm,
Their job was to run the experiments and do the next big thing. But they were losing back in the 80s. They just kept losing to two assholes in a garage in Silicon Valley, right? Because who had no money, no resources, no time, but they were able to innovate faster.
mm-hmm,
So in America, we shut down R&D. That doesn't really exist in big companies anymore.
mm-hmm,
But we replaced it with M&A, right? We replaced research and development with mergers and acquisitions. So now what big American companies do is they just watch all the startups, wait for one of them to spike, and then they buy it up and take it to their global marketing, manufacturing, distribution, all the things that a big company's good at. And that's a way to have like a relationship with innovation.
mm-hmm,
So instead of trying to become innovators themselves, which they're not likely to succeed at,
mm-hmm,
they figured out how to have a relationship with the people who are good at innovating. In this description, it's startups, right?
mm-hmm.
So that's a good example.
Oh wow, that's really great, and it was very wise actually. Thank you so much for sharing. And moving towards recent, like a lot more in the boom is machine learning and AI. So,
Yeah.
how do you envision the future of machine learning and AI, and what advantages or the potential disadvantages can it bring to the society?
I couldn't be more excited about what's possible with the machine learning toolkit. I mean, I'm very critical of the notion of AGI and these ideas that people have about artificial intelligence taking over and turning us all into pets for robots or something. I think those are very irresponsible and dystopian stories.
Mm-hmm,
Machine learning is just another tool in the toolbox. but it's very powerful, and it's so powerful. I'd say that if we didn't invent any new technology for the rest of my life, machine learning, even if we don't invent a better machine learning algorithm, there's so much there right now that we can use to reinvent everything that we could stay busy for the rest of our lives. I think it's the most important thing we have. And I think that when I was talking about that gap, the gap is made much bigger by machine learning for every business, every industry, every problem. Right now, that because of the potential in machine learning, we can do everything so much better than anyone has ever been able to do before. So I could not be more excited about it. And I think, the way I think about it, of all the problems in the world, that exist, the potential to use machine learning to go after them is higher than almost any other tool. Right? When you look at all the technology in the world, the most valuable technologies we have been computers. That's been true our whole lifetime. Right? There's a lot of other technology, but most of it is made possible by computers. Computers are generally applicable, and so I'd say computer technology is like 90% of what's valuable, and of that, machine learning is 90% of what's valuable now. Right? Meaning it's powerful and underutilized. Right? And so the job for you and I, and for all the folks from Data Science Go and in the data science community, our job is to get our heads around what those tools can do and what the problems are. Like, our job is to match those things up. Right? And we don't, it's not about inventing the next machine learning algorithm. We don't need to do that. Academic machine learning scientists are working on that. That's fine. DeepMind can work on that. OpenAI can work on that. We don't need that. What we need is a whole generation of data scientists who can understand a problem and figure out how to use the data science toolkit with machine learning algorithms and with, all the different kinds of computational modeling we have and stuff, and bring that together to help humans make better decisions. Right? And that is the most powerful thing. And I think people don't have any sense right now of how much potential is there for humans to do a better job if we start to use those tools. We're doing a lot of very poor decision making right now using our intuition. And intuition was an amazing and evolved capability that humans have, but we're kind of at the end of how far it can get us. Now we need to use data to make decisions, and that's what this toolkit is about. So I think I'm so excited because I think we're at this moment in time where the technologies have been created, but they're still very technical. We don't have something like Excel for big data, right? And so the tools have been in the hands of coders and academics and people who can code, and that's a relatively small population who don't always have a good sense of perspective on the problems we're trying to solve. And so if you look at like what happened in the 80s with something like Excel, is we were able to close that gap. Now we could bring the tools to the people who understood the problems. And Excel has been very powerful, and for 20, 30 years now we've been living in a spreadsheet world where people could use computers in a general way because of spreadsheets. We need to get there. Right now we have a pile of Python scripts and we have problems. And so the people who can marry those up are few and far between. What we need to do is make more of those kinds of people who can help bring this. So we need two things. We need people who can bring those tools to the problems, but we also need to make better tools that make the data science toolkit more accessible. And that's really going to have powerful effects on the world. I mean, I'm really looking forward to the day when we manage our own cities the way we manage SimCity, with computational models, with lots of experiments in software before we make decisions in the real world. Those kinds of things. So yeah, that's how I see it.
Yeah, that's great actually. And are you working on anything specific in the day in this area actually?
Um, yeah. So what I've been doing is trying to articulate. Part I'm really good at is that interstitial connection, trying to understand a large scale problem
Mm-hmm.
and the technologies that we could bring to it. And so I'm pretty good at defining a vision for how the technology could have those effects. And so you could see how I tried to do that with you know with food, with apparel manufacturing, and I'm trying to do that for as many different industries and problems as I can. And sometimes that just means advising companies, and sometimes it means helping create startups and things like that. And then sometimes it's I'm trying to get you to think this way too,
Mm-hmm.
right? Because there's a limit to how much I can do and how much I'm good for. But if I can get you to be thinking this way and your listeners to be thinking this way, then I think we can make more progress. So I'm trying to do some of that.
That's great, actually. And I'm really enjoying talking to you. So thank
Thank
you
you.
so much once again to be a part of my
Yeah.
Saturday podcast show.
Yeah.
So moving towards our next question is about, your Singularity University. So what does it specifically do,
Sure.
and how learning things in different way can be made possible for everyone?
Well, Singularity University is uh, and basically trying to help entrepreneurs and business people from all over the world learn about how we operate in Silicon Valley,
Mm-hmm.
right? That's how I think of it. In Silicon Valley, we get a lot of benefits from having a community that's very technical, that's very aggressive about adopting new technology, understanding it, using it to go after every market opportunity, and in some sense, go after problems. That's a wonderful thing to be a part of. And almost anywhere else in the world, it's hard to get quite as much of a community around that. And so Singularity University is a way to kind of join a community that's trying to learn how to internalize those concepts. It's not because we're right. Like
Mm-hmm.
Silicon Valley has a lot of problems. It's not because of that, but we've been the most successful in the world at adopting new technologies and aggressively reinventing the possibilities that they give us. And so, going forward in the world, it would be great if it wasn't just Silicon Valley that was so successful. But part of how I see improving that is, I want the rest of the world to learn. Here's how we do it, not because it's right, but because it's at least what you're up against, right? Not because you should try to do it the way we do it. You should try to do it better,
Yes.
right? And that's really what I'm hoping to accomplish by being on the faculty. I get to share my perspective with people from all over the world there, and it's not because I want them to do it my way. I want them to do it better.
Mm-hmm.
And I think that if they start with a clear understanding of how we do it, that'll give them a chance to innovate beyond us and to create a better culture and a better environment for innovation. And I think they set their sights too low. I've been to all over the world. I've been to like the Silicon Valley of Europe and the Silicon Valley of Latin America, and that's not the right goal.
Mm-hmm.
First of all, it's not going to work, and second of all, the setting your sights too low. We need to go beyond Silicon Valley. We already have one of those. We don't need another one of those. We need something better. And so that's kind of how I think about it. People from all over the world come to Singularity University. They get a crash course in, AR and VR and computational modeling and machine learning and drones and, like all the stuff that's going on. And they learn about that. And that's important because it demystifies some of these technologies that sound really complicated. And then they get to meet a bunch of entrepreneurs and see some tech companies and startups and learn about like how we operate, so that you can fill your head with how that works.
Mm-hmm.
and because some of it's valuable to adopt, and then some of it is bullshit you don't want anything to do with, and getting a good view of that, I think, is helpful just to calibrate. So that's the thing. And then Singularity University has been really great about promoting what we call like exponential thinking, really understanding the power of technology to change the world and try to aim entrepreneurs at bigger problems. Go after the sustainable development goals, go after a problem that a billion people have, instead of just trying to make $1 billion. That's the kind of thing that really matters. And so it's been a great community for people who want to, go after some bigger problems instead of just making more enterprise software or iPhone apps.
Yeah, that's great actually, and really very good initiative, I feel.
Yeah.
Moving towards little closer towards this podcast is that, truly it shows your passion and the interest towards the
Thanks.
technology and the innovation, and you are truly leading that. So what is your leadership style, and any leader that you always admire or follow?
Yeah, that's interesting. I mean, my leadership style is basically antagonism. So that just means I'm going to tell you what I think, and you can take it or leave it. And hopefully that will inspire some people to try and either show me why I'm full of shit and do something better, or at least try to raise their or elevate their ambition. I think more successful leadership styles probably involve, being patient and helping people, advance in a more methodical fashion. I'm a little bit more shock and awe. So yeah, I don't know. It depends on the context as well. So
But I feel like, yeah, you are in the innovation. That way, I feel like a lot more matters rather than, leading someone. It is more or going to be a mentoring, but when the person itself finds some idea or something, that person needs to be responsible. So it makes sense to me actually, the way you said that, either you do it or either you don't do it. Yeah.
Yeah, I mean, I'm a big believer in personal responsibility and taking charge of what you do with your own time and energy and talents and attention, and so I'm just trying to give people a broader set of possibilities, and if I can show them how I see the world, which is probably at one extreme, then they can kind of figure out what makes sense for them. And that it's hard for me to do everything, and so that's probably the thing I'm best for. I don't know. That's how I think about it.
Yes.
Yeah.
Thank you so much for sharing.
Yeah.
Moving towards the guidance to the audience, actually, any books or online courses, kind of, would you like to recommend to the audience?
Yeah, what I think is that there's one of the things that's wonderful about learning to code is that you're basically you are learning a language. You're learning to communicate to a machine, but for that to work, you really need to be able to express yourself in a very logical fashion and in a logical progression. If you think through what you want the computer to do in a way that makes sense, then it can't do it, and it's just going to give you errors. And so that turns out to not just be useful for coding, but it's a great way to think about everything else in life, to be able to think about the end game, like what am I trying to accomplish and what are the steps I need to take to get there. And if you don't learn that one way or another, you can see a lot of people end up with, they make poor decisions in their life and in their career and stuff because they're just fixated on what they want, but they aren't thinking through the choices they need to make to get there. And so I think it's really valuable to learn to code for anyone. And I don't even do a lot of coding anymore. In fact, I'm not even a very good coder, right? I learned to code before software engineering was a thing. I'm probably not somebody you want writing code on your project. If it's like figure out a language I've never seen before, I can probably do it faster than anyone else. But I probably can't. I don't know about some of the things that you would learn in a computer science or software engineering program. So but the point is, you could learn to code from watching YouTube videos now. Like, it's so accessible. There's no reason not to do it, and it can be really fun and powerful. And I think some of the online courses do make it fun. I haven't taken them, so I can't recommend them. But the second part of it is, I think, just learning. Like, we are in a renaissance right now where we have all these powerful technologies around data science, and we are at the beginning of understanding how to use them. And so I think it's an extraordinary opportunity to make yourself useful, relevant, powerful, to go learn about that stuff, and the mindset that comes with it. So when you asked about books, one of them that comes to mind that I think is a great way of just getting your head around it is Factfulness. Have you read that book?
No, I never actually. I need
So Factfulness is the last book by Hans Rosling, who unfortunately died a year or so ago, right before the book came out. Hans Rosling was a professor, really amazing guy. He did some great TED Talks, did a great job of advancing data visualization to show people how different kinds of trends were happening in the world using bubble charts. So he was kind of a pioneer in making data science accessible. But his book called Factfulness is really about, how to use a mindset around data and a mindset around making, logical data-driven decisions. And it's really a great book. It's accessible. Anyone can read it. High school kids could read it. It's a really wonderful book, and it has great examples that help people see the gap between their instincts, their intuition, and the decisions they would make based on that versus what they would do if they internalize the data and the facts, right? And so Factfulness does a really great job of helping you discover that for yourself, because we're all very susceptible and fallible. We think we're so smart, and some of us are smart, but we abuse that and end up thinking we're smart about everything when we're really only smart. Like, I'm smart about computers, but you probably shouldn't ask me about politics because I don't know. So there's things like that are an important part of self-discovery. So I would recommend Factfulness to anyone.
Oh, wow.
Really great book.
I need to order it today.
Yeah.
So thank you so much for sharing. And moving towards our last question is about, always it happens that, a person, when it tries to enter the new field, when it comes to the career or grow in a particular field in the career, actually, sometimes people struggle to achieve that. So any tips or advice to the people who are looking to grow or enter into a particular field for their career?
Well, I think, probably a better thing for me to do is talk to the people who don't know what to do. If you want to, there's kind of nominally like two tracks you could get on. One track is like, I'm going to be a dentist. Like a dentist, on the day you graduate from college and become a dentist, you can get a spreadsheet and figure out probably to the dollar how much you're going to make over your entire career. Right? You can only see this many patients. You can see this many patients a day. There's this many days in a year. You can charge this much. Like, exactly what you're going to do. And there's probably very little question about whether, what work you'll be doing 20 years from now. It's pretty much the same work you're doing today. And that appeals to a certain type of person. Like, they like that predictability, the stability. They like excelling at doing one thing really well. And that's great. I'm probably not very helpful at giving anybody advice if they want that much certainty about their career, right? In my career, I can sort of paint a picture that makes it look like a genius master plan, but I never knew what I was doing. Right? I never had a plan. I still don't. Right? I'm just going to go. What I've always done is found the coolest project I could find
Mm-hmm.
right?
Mm-hmm.
What I was most excited about, because if I was working on something I was interested in, I knew that I would learn a lot
Mm-hmm.
and I would work really hard,
Mm-hmm.
right? Because if you're interested, then it's not work.
Mm.
Like your brain, if it's interested, then you stay engaged. You wake up thinking about it. You go to bed thinking about it. You perform well. You learn more. You'll spend all night trying to figure it out. Like all that's easy and fun.
Mm-hmm.
That's a delightful way to spend your life, and I've been doing that my whole career.
Mm-hmm.
Most people give up on that because it's got a lot of uncertainty and it doesn't sound like a plan, and it's hard to get your parents to think it sounds smart, and there's no prestige in it. There's a lot of those things. But so I think a lot of people are just optimizing for safety and security and predictability in a way that it isn't really what we need so much right now, right?
Yeah,
Like
right
what
now,
we
actually,
need,
the corona situation shown that.
yeah, we need people who are resilient, who
Mm.
can figure out how to make themselves valuable,
Mm-hmm.
right? Who can adapt and change. And so, I'm probably a good example of that. And what I think is, if a way to maybe get there is to think about, okay, what's your worst case scenario?
Mm-hmm.
Like you're probably living it right now is the truth for most people.
Yes.
Your worst case scenario is like, okay, lost my job, girlfriend left me, iPhone battery is dead, I got to sleep on my mom's couch. Like it's bad, but it's not that bad. Like
Yes.
you've been there before. So what? Why would you sacrifice having a career that you love and enjoy and working on things you're excited about and passionate about
Mm-hmm.
to avoid that? It's not a trade-off that actually makes sense, but most people, without even thinking about it, choose to go to college, get the degree, become a doctor, do what makes their parents proud, and hate every minute of it. And some, it's not a good. That's why I think it's not a good decision-making process. So I think a lot of people are over-optimizing for security, and instead of that, they should optimize for resilience.
Mm-hmm.
They should optimize for really going after the things that are exciting to them, that they believe in. I only work on things that I'm excited about and believe in, and that has paid off. So
yeah, that's great, and it's really very wise advice to anybody to have actually.
well, thanks.
Most of the
Don't-
time, most of the times it happens actually, as you mentioned, that people fall for the job security, or it always
Yeah.
happens that it's a pattern, right?
Yeah.
Because parents enforce children actually to take the education in the direction where they can most probably get into the job and
Yeah.
earn for themselves.
Yeah.
So it's all come down to the financial stability, being independent,
Yeah.
job security.
And I'm not to disparage anyone who has to make those choices. Depending on your situation,
Mm-hmm.
you might really need that stability and security, and that might be the best choice for you. I'm just trying to also sort of validate the opposite end of the spectrum, where because
Yeah.
that's what I've done.
Yeah, but it is very definitely important that the way you mentioned that it is important to explore, and sometimes it's important not to
Yeah.
have the plan and
Yeah.
go follow your passion. And
Yeah.
so thank you so much, and
Yeah.
really enjoyed talking to you,
Thanks.
and it's really great to see you back again. So thank you, really appreciate all your time, and audience, definitely you are going to enjoy this episode.
Good.
As I always say, until we meet, happy leading, let's live together. Stay safe, bye for now.
Awesome. Thanks so much.